up, so we got those. We can get rid of those in a second, so here, let me just copy those onto this sheet. And I'll change them around here in a second. Okay, I write too big. Alright, so now let's see how we can get these all to work together. I want to solve for all of their t's, and then I'm gonna solve this for t, and then I'm gonna solve this for t, and then I'm gonna plug my t's back in here. I'm also gonna solve for these equations, so I'm gonna plug these two into my frictional force, and I'm going to have everything in terms of m's, g's, and a's, and we're going to see why that is here in a second. Alright, so I'm going to leave those, and we'll solve for this one too. So I'm just going to subtract the T2 from the right side and then subtract the 2MA from the left side. That'll give us that in terms of our tension. Okay, so now I'm going to plug these two equations. Actually, here, let me solve for these two so we have our frictional force to plug in there. So you can still see that there. So I'm going to solve this. So solve my normal force equals 2 mg. Alright, you see that there, and that makes it, I mean, we probably could have just said that we could probably say that from the start, but it's nice to see it all played out in algebra. It makes it really clear. So, and then our frictional force also just goes to mg. Right, so this is what we want. We're going to plug this back into here. So now let's pull these on. I'll probably have to switch out a sheet again. So, let's see, get everything in clear view here. Bam. Okay, so I'm going to plug this one in first. So we have 2 mg minus 2 m acceleration. And then we have minus, so I'm just going to go ahead and distribute out this negative, so it'll be negative our mass times acceleration. That'll be negative our mass. Oh. Okay. Times gravity. I'd be really bummed out if I make it to the end of this and I made some huge algebra mistake, which is pretty likely. We'll see. I have a good feeling about this. Alright, so alright, and now we're plugging this in for our frictional force. Which is this negative 2 mg, and then that all equals 2 mass times our acceleration. Okay, so now this is really nice. We have everything in terms of these m's they gave us for mass. So we can just go ahead and eliminate them. Bam, 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 and done. All our m's are gone. We can kind of combine down some of the stuff too. I'm not going to do that right off the bat. It'll be a little more clear after we write these without m's, without our masses. shorter than there again. Okay, there we are. Okay, so kind of tilted it on us. So I can combine some of the stuff. First of all, I want to get our coefficient of friction onto the right side because that's what we're solving for. So now I'm gonna put 2G on there. Then I'm gonna subtract this from this side, so I get all my other terms on the left side. So I'll just go ahead and start at the beginning here. And let's combine some of these. So we have, actually I'm going to write it out again and then I'll start combining stuff. So it doesn't get too confusing and I don't make a mistake. Minus 2a as well. Okay. Right, so far. Okay, so we have a negative g and a 2g here, so we can combine those, and that makes positive g. Okay, so we're on those. All right, and then we have negative 2a, negative 1a, and another negative 2a, which gives us negative 5a. Okay, and then I'm going to go ahead, so I don't run out of, so I have to start off on a new, well, we're going to have to start off on a new page anyways. So let's go ahead, like that. Okay. So now I'm going to divide out our 2g on this side. We'll have everything in our terms of our coefficient of friction. We also have numbers for everything else. So we have all our unknowns are gone, and now we're just left for stuff that we know what they are and we can solve for. Okay. We'll have our coefficient of friction. So we have to go back to the first page so we can remember what we had for numbers. So let's see if we can get this all in view. That's not with everything else. Alright. Not really going to be able to see anything, are we? There we go. Okay. So we have a little equation. Now let's just have a look at this. Okay. So we have our acceleration is 0.5. And what else do we have? Oh yeah, we have gravity, which we're going to call 9.8 for our reasons. So I'll just throw that in. So we have our little equation here, and we have our magnitude of acceleration. Magnitude of acceleration equals 0.5 meters per second squared. Okay, and then we have gravity, which we're going to call 9.8 meters per second squared. Okay, and we'll just plug those all in, and that'll give us our solution. And this is really the hard part, was getting to this, and not even getting the algebra. Really, it's just the setup. But it's the most dangerous part. The algebra is tricky, but it's not conceptually tough. So. By 2 times 9.8, which should give us somewhere in the ballpark of 0.37. Alright, and I think that's it. Let me see here. Yeah. So, all right. Fun stuff.